So here you go. Is it working now? Can you hear me? This doesn't go through this. I just gotta yell. No, but for that, is it just yell? Maybe you could just can you hear me? Matt? All right. We're streaming online, is that correct? Okay. Hi everyone. All right. I gotta yell because we don't have a internal PA system, but that's okay. Can everyone hear? Can you hear me in the back? Hear me in the back. Okay. Cool. Well, welcome everyone. I am honored to be here. My name is Marcelo Scambaluri, as Amy said. I live in Los Angeles, and I work for a structural firm down there called John Martin & Associates. And I wanted to come here and talk to this fine group about something I'm passionate about, something that's kind of on everyone's mind, kind of the new fad right now, which is Dynamo. Right? So we're gonna get to know each other real well in the next hour. I won't let you stay quiet because it's very interactive, this presentation. And if you have any questions, holler, any comments, yell it out, raise your hand. I'd love to hear them. Okay, we're all just gonna geek out on this stuff today. Okay. So I need to kind of learn who I'm dealing with here. How many people have actually used Dynamo? When I mean used, just have downloaded it and at least opened it up on their computer, and at least downloaded it and opened it on their computer. Really talking about intro to Dynamo, but also Dynamo appreciation. Okay, I'll explain what Dynamo is. How many people have not heard the word Dynamo before in relation to the AEC industry? A few? Okay, and the ones who have heard it, how many people have heard the word but haven't used it? Let's try that. Oh, look at that. This is the group, Amy. Dynamo appreciation. Why did I call it Dynamo appreciation? Well, I call it Dynamo appreciation because first we got to learn what Dynamo is if you want to use Dynamo. Then you got to appreciate what it does. And once you do that, then you can use it to your advantage. Okay, so let's go ahead and take a trip down memory lane on how Dynamo was developed a little bit, and then we'll kind of get into the meat and potatoes about it, all right? Like I said, if you have any questions, holler, because I'd love to hear them. Let's get started. Give me a second here. Let's see. Got some slides here. Oh, what is Dynamo? What is Dynamo? Let's start with this one. Hold on a minute now. What is Dynamo? See that? Can anyone see that? Because we're going to be looking at text that's a little small. These lights can't go down, can they? I mean, we've got the windows open. Suppose not, right? Can you try to find a switch to turn, at least make it a little better? What is Dynamo? What is Dynamo? At its core, Dynamo basically is a visual programming language that runs in a visual environment that uses a visual programming language that is extremely easy to learn, and we're going to go over that, how to learn it. Ridiculously simple how to learn it, okay? It reaches into Revit and it grabs and talks with the Revit API, okay? Has anyone is anyone doing any API coding in their office or using it, an add-on in one form or another? Anyone? Okay, those traditional API programs use these two languages, Visual Basic and or C#, right? And what do you have? Do you have programmers in your office, right? Okay. So what Dynamo does, which is this one right here, it tells the other two, look, I'm the one that's going to talk with the Revit API. I got this little cartoon that made up for this, right? This is the house of Revit, this very mysterious API that kind of looks out the door, right? And this is basically the database behind Revit, right? And the API has the key to all that data. The API, which is the application program interface, right? Previously, only these two could talk to it, which is just text-based language, right? The developer said, okay, well, we know that we know that there needs to be an easier way for all the users to talk to the API and extract data from the database within Revit. How do we do that? Let's make a visual program called Dynamo that will talk with the API. So now the C# and Visual Basic, they kind of take the back seat, and Dynamo does the talking. Okay, that's really important, because when Dynamo does the talking, then everyone can program in Dynamo. And if you can program in Dynamo, you can tap the API, which means you can tap the Revit database, which means you can see everything behind Revit. And the point is that it exposes more functionality for you than just what you have with the graphical user interface. Okay, so that's what Dynamo is really in a nutshell. It gets everybody the access to the database behind Revit that then gives you more functionality than you would have with just the graphical interface. Okay? So that's basically what it is in a nutshell. Are there any questions about that? It took me 4 months to wrap my head around that concept, but we'll get into it a little more about it. So if you Google Dynamo, you wouldn't really get that explanation. You'd get this long-winded thing from the developers. Basically, Dynamo is supported with its development with Autodesk. Okay? That's really what it is. So it's kind of a seamless integration with Revit. And it does work as an add-on, and it is completely free. So there's nothing preventing you from getting back to your office, if you go back to your offices after this lunch, from getting on the website, dynamobim.org, and downloading the latest version, and then firing it up on Revit and go. Okay? There's nothing preventing you from doing that because it's completely free. But what Dynamo does, again, is so that's kind of its interface. Then what Dynamo does, it actually is its own parametric, it's its own environment that creates parametric geometry. That's what Dynamo does. It makes parametric geometry. It makes cones, it makes surfaces, it makes arcs, lines, circles, it makes all that primitive stuff. But it also reads external databases, which is also the API in Revit. So you can build something in Dynamo, and then you can extract data from Revit and stick it in. Okay? So you can it kind of has this kind of symbiont relationship between Revit. You got Dynamo, you got Revit. Okay? And you can build geometry in either one, of course, right? So basically, it is a program that creates parametric geometry. And isn't that what Revit is? Isn't Revit a program that creates parametric geometry? Isn't that what Revit is? Isn't that what Revit is? Okay. So Dynamo kind of does the same thing, except it has a bit more iterative functionality through its programming language. All right. And so to emphasize this a bit more, that's just a flow chart. I already went over that.
Can geometry be opened by somebody else in the Revit?
Dynamo to open up Dynamo geometry. Just like if I gave you a Maya file, you would need Maya to open up that Maya file. But that's not a limitation, because all you have to do is say download it. It'll take you 10 seconds, then fire it up. So that's not really a limitation. Yes. How does it the question was, how does it relate to structural analysis software or interact? We'll get into that. I'll mention that a little later, and if we want to talk later, we can talk later. But that's not really the focus of this class, but it certainly could do that. Okay, and I'll explain a little bit of how you can get that done. Okay, so when I heard a bunch of hands of people saying that they've heard Dynamo, but they haven't used it, right? That's the majority of this group, and you're the ones I want to talk to, because I was just like you. I heard the word Dynamo, and I knew it was being developed, and I saw it being developed for a bunch of twisty shapes. And even me, I've modeled the Revit cow and the Revit elephant and all this whacked out stuff. And I was saying, I'm not going to touch Dynamo. I don't need it. My projects in my office aren't have all those twisty shapes. I'm not going to learn it, okay? Because this is what all the examples that came out of Dynamo when it was first being developed. Right? That's the worst thing I could have said. Okay? That's the myth I want to dismiss today. When you walk out that door, I want everyone to realize that it's for you. You can use Dynamo in your office, even if you don't have twisting geometry like this. That could be further from the truth. This is actually a special application of Dynamo. The reason that a lot of these examples came out early Dynamo development, by the way, everyone who's heard the word Dynamo, the examples you've seen kind of online or in social media or in the media, is this really what you've seen, these kind of complicated twisted shapes? Let's hear hands. See hands. You see these kind of complicated twisted shapes, right? That's, okay. The reason that happened was the team that's developing Dynamo also developed the mass and adaptive component environment. So a lot of the examples and things they were working with were these kind of complicated shapes. But that could be further from the truth. It actually could be used for anything, and we'll talk about practical examples in a little bit. But yeah, again, here's some twisty shapes, right? Google Dynamo, and go click on images. You're going to see all this stuff. This was work done by Case as well. Fine group, by the way, out there. They do some good stuff. They do some twisty shapes, but you can see you can get Dynamo examples like that. But that's not what Dynamo's all about, okay? It's not, right? I'm going to show everyone that it's not really just about twisting shapes. So then, hold on, we'll get that in a second. So then this is going to drive this home for you, okay? Does anyone have a pointer? Pointer? No pointer? All right, I'll point. Okay, so Dynamo. This is kind of the environment in Dynamo. Basically, it's just these boxes with wires. If you see boxes and wires, you're in a visual programming environment. This is what Dynamo uses, okay? This is a program that sets up how to change the titles and the sheet names and sheet numbers inside a Revit project. These are the Dynamos that you use to do it. Can anyone tell me what that is? This is a macro inside of Revit. This is the API that we kind of know and love, and all that text-based programming. Do you know what that does? That does the same thing. Okay? So can you see see it now? That renames sheets and renames numbers on sheets. Names and numbers. So does this. Okay? So what would you rather learn? Would you rather learn that? Or would you rather learn this? Okay? And what these boxes are these are discrete functions, and within the Revit API, there's what they call methods that are discrete functions. Rename this, rename that, do this, do that. These boxes inside of Dynamo are just discrete functions, okay? And they want to feed information in, and they send information out. And the way you flow information between them, so like this would be the sheet name, and this would say change the sheet name. So you type in the sheet name and you feed it in. It says, okay, I'm going to change the sheet, and I'm going to feed out the sheet that has a change on it. Okay, so that's basically how it works. Okay, so you don't need any programming experience at all in order to use Dynamo. You will be an instant programmer. Okay, so when everyone leaves here, got homework time for you. When everyone leaves here, I want everyone to download Dynamo, open it up, lay a few nodes down, and we'll show you how to do that. Wire them up, save them, and then get it on your resume that you're a Dynamo visual programmer user, because it's the wave of the future. The wave of the future, okay? There's already talks about families having Dynamo-type applications applied to them. This whole visual programming. Has anyone heard the word Grasshopper before? Okay, Grasshopper is also another type of visual programming environment that kind of deals with the Rhino database, and it's very similar in comparison. Things are moving this way. So the fact that you're here is awesome. Even if you never wanted to use Dynamo in your life, you'll want to download it, save it, get it on your resume, and I guarantee you there's someone in your industry that you know that's going to want to use it. So learn it for yourself and teach them. Even if you don't want to use it, become the hero in your office, and you'll be awesome. Okay? So is anyone a little bit clear on what Dynamo is? We'll get into some examples, but you kind of understand. Remember, Dynamo's for me. Dynamo's visual programming. I can learn Dynamo. Dynamo taps the API, Dynamo sees the Revit database, and I need to get Dynamo on my resume. Okay, that's all you need to remember, those 6 things, okay? All right. So can we stop? Are we done, Amy? Can everyone want to leave, or you want to see some examples? Okay. I saw a question back there. Yes. Yes, the question was, is this under the larger umbrella of computational design? It is not. It is not under the umbrella. It is the umbrella. Dynamo is the embodiment of computational design, and everyone will start to hear that word. Okay, and really what it is Revit does. Computational design basically means Revit is an excellent platform for modeling parametric geometry and documenting it, right, and making your sheets. But where it lacks a bit, okay, we can have arguments this back and forth. Where it lacks a bit is in the early phases where you want to run a lot of iterations, where you want to change things, and your roof is changing, and your your ridge line is changing on your roof back and forth, and you're looking at all these examples. I mean, there's design options, right? But this whole computational design idea is that you do your design and your iterations and your computations early in a very fluid, interactive way. And the way to do that, if you don't want to brute force it in Revit, is to use Dynamo. And Dynamo kind of came out of this whole industry where we're all moving, we are, whether you like it or not, into computational design, where design happens early, you get these iterations. So, I mean, what do? You use SketchUp? I mean, what are you going to use? Use Rhino? What? You can use Formit? I mean, those are all early. Dynamo has that kind of mathematical robustness to actually do a lot of those iterative computations, and we'll talk about that in a little bit, okay? So does that answer your question? It is? Okay, very good. So Dynamo and Grasshopper, that does the same thing. So I said, okay, well, now that I'm learning Dynamo, I've actually only started using it in September of last year. So I'm kind of in a unique position to teach everyone here what it is, because I had to go through the ringer, and no one looked over my shoulder, and no one simplified it for me. So I'm glad I can share that with you today, and how it's really a simple thing. But let me show you some things I did. So I said, okay, Rhino and Grasshopper are very similar. I said, what if I build a Grasshopper inside a Dynamo? And that's what I have here. Actually, that's technically a Cricut because it's laser longer, but it used to be shorter, and it was a Dynamo. It was a Grasshopper, kind of an artistic statement. I just kind of put it out there to let people figure out what I was doing, right? But it's to a Grasshopper, right? Okay, so anyway, there's a Grasshopper inside a Dynamo, okay? So you can take that any artistic way you want. I said, oh, let me take it even further than that, because that's just a bunch of plates. This is Dynamo geometry. It's not Revit geometry. We'll get into that in a minute. I said, oh, let's see if I can rebuild the elephant inside a Dynamo. I did it, okay? So this is the elephant rebuilt inside of Dynamo, but it only takes 2 more nodes to send it into Revit, and we'll explain that when we get into later. We're actually going to talk about the Revit Cal. And then I said, okay, well, you know, this is really hard to see. But anyway, you can deal with topography, and you can expand. You can really use some outside tools that Dynamo can use, like that's Paint, you know, the simple Paint program inside of Microsoft. I just wrote up there, Dynamo and Topo, and you can actually emboss that on a Topo surface inside of Revit, and that's what you kind of see here. It's a little hard to see, right, but you can see that. So you can actually, if you wanted to, you could actually take your paintbrush and start making, you know, depending on how heavy it is or how light, you could actually build up mountains inside of Revit using Dynamo, just depending on how you wanted to kind of shape it and move it. So you have the, I'm not going to show that today because this is kind of an intro to Dynamo, but you have that ability. And you know, over there, it's a face of a dragon. Can you see that? Wow. Kind of embossed in a, also inside a Topo surface. Okay. So the point is, Dynamo, you have the ability to use Dynamo and do all these twisty, crazy shapes. You can do crickets and grasshoppers. You can do elephants. You can do topography. Or you can simply just change a value, any value you want. Right? Does anyone use reporting parameters? Has anyone use a reporting parameter? How many people love them? Everyone loves them? Okay. Did anyone try to set something equal to a reporting parameter? Anyone ever try to do that? And a few people, right? The developers actually lock you down, right? And they say you can't, for the most part, set a reporting parameter equal to something else, right? Or the other way around. But Dynamo actually has the ability to work around that, okay? And we'll get over that in a minute. Because all you do is you say, I want that parameter. Dynamo extracts it. And you say, I want to make it equal to that. And then Dynamo shoves it in, back in, okay? So that's all Dynamo does. It just starts grabbing and pushing, grabbing and pushing. That's all Dynamo does. Plus it builds its own geometry. We'll talk about that. Grab the database, shove it back in. Grab from the database, shove it back in, okay? Or grab it and don't shove it back in. Or shove something in, don't grab it, okay? So that's really what it is. It's this very interactive environment. And because Dynamo was built by, I'm not supposed to say built by Autodesk. I don't know why they don't let me say that. It's being supported, its development is being supported by Autodesk. It's a very seamless interaction. Oh, okay. Another good question. I think these questions aren't scripted, believe me. The question was, is Dynamo open source? Dynamo is open source. So in theory, if you don't like something in Dynamo and you want to make your own nodes, or you want to change it a little bit, the entire source code is open to you to actually do that. Okay, so it is open source, completely open source. Bit new for Autodesk. If you actually read through the hundreds of pages of the user agreement, there's no mention of open source. So I think they're still kind of working the legal issues out on that. But anyway, okay, is everyone kind of on board? Yeah? Okay, cool, let's see it. You had a question? Oh, show me, okay. I had to get through that intro. Okay, all right, let's do it. So what I decided today was to give you not only just boring, place a node, do this, do that. I have actually been teaching Revit classes, as Amy mentioned, to the Revit Technology Conference in Autodesk University for the last 3.5 years. And what I typically do when I teach a class is I find out what problem is there in Revit with the graphical interface, what limitations there are, and I come up with the workaround. What I decided to do was take a lot of these workarounds that I've been teaching over the years and seeing how Dynamo can actually attack that problem. So I'm going to show you a problem inside of Revit, a limitation. I'll show you the graphical user interface workaround, and then I'll show you how Dynamo can deal with it. So in the end, if you don't want to use Dynamo, you still have a way to solve the problem, okay? So I'll show you what I mean. Any other questions before I continue? No? Yeah?
Are these particular solutions available to your background in coding and software, or are these kinds of solutions available to leads who are not necessarily coding but learn the interface of that?
Question was, good question. Question was, are these workarounds that I've come up with, when you mean workarounds, you probably mean these Dynamo definitions that I'm going to show you, these nodes and wires. Have I figured these out because of my intricate coding background, or could anyone learn it? The answer is no to one, which is I have no coding background, okay? Just like all of you. Well, I guess I was like all of you in November, okay? I have no coding background, okay? And I just kind of learned it on my own. So that should answer your second question, which is, could anyone learn it? Absolutely. Could anyone learn it? Absolutely. So let's open Dynamo. Is that AC going to be coming down anytime soon? You're killing me. Is this how you roll in Portland? Hey. You guys are killing me. All right, the show must go on. Yeah, you're true. Oh. All right, so let's do. Okay, let's do this. Yeah, I'm going to. I do get a kind of interact. I geek out about this stuff, so I do get kind of sweaty. So just deal with it. But let's start with a simple example, sort of. By the way, there was a handout available. Did anyone get it, or download it? Anyone? No one? Amy, no one? You didn't download the 93-page handout? Oh my goodness. Huh? Well, it's digital. You don't have to print it. Okay, let's do this. Are we recording? Now, are they seeing? Sorry, everyone. Are they seeing my screen, or are you just filming the screen? But are you just filming the screen? Oh, okay. Okay. So some of the smaller print they might not see. We're live streaming.
Yeah, the small print.
Okay. So okay. All right. It's probably too late for that, but it's all right. We'll deal with that later. No, it's okay. All right. So just give me a second. Let everyone absorb what I said. Let me open that up. Start thinking about how you can use it. Okay, let's do this. Okay. So what we got here is just a kind of a fictitious, not fictitious. I mean, this was a canopy that I had to deal with before. All right, so what we got is basically a, let me try to grab that mass. Love this example. Oh. Taught this at Autodesk University 2012. Question is, you have a curved surface like this. It doesn't have to be curved, right? You can have these planes, right? Roof. How many people have, oh, look at this, thank you. How many people have done some kind of roof modeling inside of Revit? How many people? How many people have tried to get those beams tucked right up against the underside of that roof and have had a complete success? 100% success. Okay, the structural engineer, of course, is going to say that. Don't worry, we're going to pick on you later. It's not an easy thing to do, right? Okay, so this is the problem we're going to have. Here's the graphical user interface solution, then I'll show you the Dynamo solution. Okay? Canopy framing. We want to put a beam that follows this undulating surface on this grid. Here we go. Level 1, right here, along grid C, okay? So grid C, we want to put a beam between these girders. We'll make it continuous, okay? So what's the first thing you do? Huh? You cut a section? Is that what you would do? If you put a beam on grid C, would you cut a section? Come on, you got to say, yeah. Don't worry. Okay. You cut a section, and then what you would do, you'd click beam, structure. Yeah, by the way, if you don't have that structure tab put on your 2014, 2015, get it on there, okay? Get it on there. Oh, you need systems too, and you need architecture. I might argue this should probably be in front of that, but anyway, that's the way it goes. You could do that. How come you can't just drag this and put it over there, huh? Ooh, what? Control. Oh, nice. Okay. Hey, okay, there we go. Hold on now. I'm just gonna be a riot. Let's just do this. Okay. What? Wait, I got it. You can't go back? Okay. All right, anyway. Enough foolishness. No, there's gonna be a lot of foolishness here. Believe me. This is I love talking to user groups. Oh, it's awesome. Love it. So what would you do? Come to your pick tool. I put a framing elevation on, which means the work plane's already set to grid C. If you don't know about framing elevations, better Google that, okay? Even if your architect's got to use those framing elevations. What I do, come here, and I start clicking the bottom of this, right? Oh, what happens? What happens? When I try to click this, what happens? Nothing, right? Oh, yeah. So the developers are teasing us, is that right? Yeah. So what do you do? This is what what do you do? Oh, you come here to spline. Come on. And then wait, what is this? Tube? No, I don't want to do tube. Yeah, 30 by 90. Oh, yeah. Okay. So what do? You start doing this. You start kind of approximating that. Come on, how many people have done this? I've done it. Come on. No one? No one has used the spline tool and estimated anything? No one? Not even a wall? Nothing? No one? Hands got to go up. I've done it. Come on now. Come on. Okay. That's fine. Don't worry. I was there too. Well, yeah, that's cool, and you can kind of estimate it, right? But what a mess, right? What a mess. Actually, the way to get this edge, you want to get this edge, right? You want to get it pickable. Well, what you do, and this is what I found out. By the way, when I show a method, I always have to give a lot of background, kind of my thought process. And it's extremely important when you're laying out Dynamo nodes, believe me. So I said, okay, well, I can't pick the bottom of that. What can I pick inside of Revit? And I knew that you can actually pick edges inside of Revit. And I said, if you can pick an edge inside of Revit, then I just need to make that an edge. How do I make that an edge? Well, I can't find the intersection. There's no intersection command inside of Revit, right? Because what I want to do is find the bottom of that surface and the grid C, which would, two planes result in a curve, right? And then I can pick that curve, but I can't do that. Okay, what can I do? Find an edge. How do I do that? Actually, what you can do is then okay. But not like this, okay? Okay, here we go. I didn't think about this before, but this is the case. When you use a pick command inside of the beam command, then the beam is kind of locked in time, okay? When you use the pick command to lay a beam down, all right? And there's good reasons why you want to do that, like this, or this surface doesn't have to be undulating, right? It could just be folding, right? You can still do that pick trick, right? Or I call it the intersection method. That's what this is called. Google that and there's a lot of blog posts on it. Anyway, that's the intersection method, okay? Limitation. Now you could build it out of an adaptive component where it would move around, or a mass, and I actually taught that 2 years ago. But the problem is it's not a structural beam. And all the structural engineers, because they whine and complain, and they say, no, I need to show my structural beams in plan, right? I can't just do single lines and type in a bunch of text. It's a structural beam. It needs to be a structural beam, okay? So if you want to model a structural beam, then this is how you do it. Here we go. Dynamo. Okay, it's right there. Add in dynamo. Okay, here we go. That took 30 minutes to get here, Amy. How are we doing, okay? Doing 30 minutes to finally reach dynamo? Okay, too bad. You have to wait. By the way, it's better to do this with dual monitors. Oh, cool. It's better to use dual monitors when you use dynamo because you have you're going to be doing your programming here and it's going to be doing your manipulation here. But we don't have dual monitors, right? And you know what's funny? How many people use dual monitors in their office? Okay. Do you know how many laboratories, teaching laboratories, use dual monitors? Like 5%. Why is that? That's a big oversight in the planet, don't you think? Yeah. So help me with my cause, which is as I start to teach Dynamo, I want labs to have dual monitors. So as you're attending conferences or training sessions, please try to request that. Okay. But we'll just have to kind of work with it. Okay, here's Dynamo. I'm going to do this completely from scratch. Hopefully it works. I got a backup file, finished file in case it doesn't work. But let's let me say this really quick. This is version 7. God, it's hard to read. 7.1.3 and whatever, okay? Dynamo is in very fast development, okay? Very fast. In fact, there's releases every day. All right, that's its release cycle every day. Okay, so I go and I check every day to see what new features have popped up on it. It's amazing how quickly it moves. But for a treat today on everyone, one of the treats is I'm showing the latest version. It's in super alpha. It is 0.7.1. Right now, most examples you see out there are in 0.6. And so, all those people who use Dynamo, where are your hands? Come on now. Are you using 0.6 or 0.7? 0.6. Oh, look at this guy. He can be a troublemaker. 0.6? Anyone else? 0.7. Okay, the 0.7 has integrated a new environment, which is beautiful. I love it, and I'll show you the Revit Cow later. It's called Design Script. Has anyone heard the term Design Script? No one? A few people? Okay, Design Script basically is another simple programming language. It's text-based, but it really basically builds geometry. The developers of Dynamo were able to integrate those two, marry those two, Dynamo and Design Script. So now, any node you lay down, you could also basically use text-based design scripting to do the same thing. And there's big advantages to that. But I mean, since this is an intro class, you don't have to use Design Script. But I am showing you this is the brand new environment. And if you can't tell the difference between 0.6 and 0.7, 0.6, 0.7 has gray nodes, and 0.6 has yellow nodes. Okay, so if you see online some of those awesome examples, and those nodes are yellow, you go. I know 0.7. All right. So that's how you know. Okay. So we just laid down our first node. What is this, Marcelo? Ooh. I actually like to work backwards. Okay. I work backwards with Dynamo. Well, we're only going to get through 2 examples, but that's okay. I like to work backwards. Okay. What we need to do is we need to lay down a structural beam inside of Revit. Okay. That's what we need to do. Now you need to get a little bit familiar with the Dynamo environment. It's not scary. Don't worry. It's a program. You can't hurt it. Okay. Don't worry. Can't hurt it. You can always undo Revit if you need to. If you want to test some things out in your office, just save that file as a trash file okay, if you're worried. All right. How'd that get in there? This is basically how it's broken down. Can you read that? These are basically the two you'll float between. Okay, this is Revit. Basically, if you click that tab and you pull anything out of it and you drop a node from any of this, you will be building Revit geometry. If you pull anything from this tab, just geometry, that should be called Dynamo geometry. That should be called Revit geometry. If you pull anything from these, you see how it says bounding box, circle, cone, cuboid, curve, cylinder? If you drop any of those down and use those, you are building Dynamo geometry. And I'll explain the difference between the two. It's very confusing because you've got Revit geometry and Dynamo geometry that look identical. Okay? But that's the first thing. No one taught me that. It took me 4 months to figure that out. I'm like, hey, wait, look at that. They organized that. Great, look at that. Awesome. Dynamo geometry, Revit geometry, okay? So if we're going to lay down a dynamo, if we're going to build a structural beam inside of Revit using Dynamo, what menu would I go to? Revit, okay? Revit. Then I'd go down here to Elements. Then I'd go down here to what? Probably something to deal with structural framing, right? See this Create? Boom. Oh my gosh, look at that big thing. Don't worry, don't worry. Okay? This basically says, feed me all my information I need to know it's a structural beam. I will run a calculation and I will build myself in Revit. Okay? So let's just walk down it. The first one is curve. Now we're going to skip that, okay, because we're going to figure out what to do with that in a moment. Let's go ahead and keep moving. Oh, you know what? No, let's do that now. Forget it. We'll do it. We'll do that now. But I like to work backwards. Some people like to you program left to right in Revit, Dynamo. At least you put in boxes and wires together left to right. But I like to work right to left because this is my finished product. So if I start laying down curves and levels and vectors and structural types and all that, I kind of don't know where they're going. I like to know what the question is before I answer it. Okay? Is that clear with everyone? It's a bit backwards. That's the way I do it. Think about that. So I know exactly what to put in there, right? Structural framing. What, you had a comment? There? You like my style. Oh, with the backwards but forwards with this? Okay. Cool. Structural framing. By the way, you see this? Do you see what this is? You see this naming? This is not done accidentally. You see this structural framing dot by curve level up vector and type? Do you see this? Do you know what this is? This is actually Dynamo. This is actually design script hidden. Okay? So if you wanted to actually learn design script, all you have to do is copy and paste that into one of the design script nodes, and you'd be doing the same thing. Okay? Basically. But that's intermediate class, Amy. Maybe we'll do an online thing for that because you don't want to wait a whole year. Because if I come back in a year and everyone here is still stuck on this node, you're going to have a world of hurt. Okay? So I would hope everyone advances further than that. All right. Anyway. Okay. Wow. Curve. Curve. Can anyone tell me what curve I'm going to feed in here? By the way, this class teaches itself because you guys are awesome. Can anyone tell me what curve I'd feed in here?
Intersection.
Go ahead. Come on. Anyone? Yeah. Okay, you two. Let me hold off on you two because you're talking the whole time. I want to get something for someone else. But you're right. Okay. Anyone else? No one? What curve would I feed in there? Just an empty guess? What? Edge. Of what? Of what? Yeah, that same thing I picked, right? Isn't that right? Okay. So the question is, how do I get to feed it in there? That's question one. How do I get that edge? It's hard to see because I don't have dual monitors. Amy, we're going to work on that next time, right? Okay. How do I get that edge, which is a little hard to see? How do I get that edge from, there it is, the one we know and love. How do we get that edge from the Revit environment to the Dynamo environment? I'm sorry? Select the ID number. Yeah. Well, you're a Dynamo user? Yeah, look at this guy. Okay. Cool. He's got all the answers. Yes. Select it. Okay? But more importantly, what you're doing is you're selecting it. But you're turning it from Revit geometry to Dynamo geometry. That's what you have to do. Okay? So anytime you feed something into a node inside of Dynamo and it's geometry related, you better first change it to Dynamo geometry, okay? And I'll tell you what I mean by that in a second. So you got to first change it. How do you change it? Well, the developers put in some nice little things for us, and one is in Dynamo. Here. You go selection, Revit selection. You're going to be using Revit selection all the time, because you're going to be building Revit geometry, you're building Dynamo geometry. Building Dynamo geometry, building Revit geometry. So you need to have tools to kind of pick between the two. Okay. So here we go. Ready? Let's look for pick. Oh, here. Select model element. No. Select edge. Ooh, that's perfect. Select edge. Just lay it down. Now, if you don't know what to do, okay, just lay a node down and try it. Right? You're not going to hurt it. Okay. Believe me. This is how I learned this. No one taught me how to do it. I was like, well, I need an edge. Well, I need to select an edge. What node would I use? Select edge, maybe. Yeah. Okay. Select edge. So.
What is the reference?
I'm sorry. We'll get to that. There's another trouble causer in the audience. Question is, what does that reference do? I'll get to that in a second. It really shouldn't be called reference, but it's called reference. There's some nomenclature inside of Dynamo and Revit that aren't quite consistent, but just deal with it. Okay. Right? Yeah. Anyone an API programmer? Come on now. Come on now. Anyone an API? Okay. He's okay. This now. Okay. No. It's reference in the API. Awesome. Exactly right. I'm going to pick on you because you're an API programmer. In the API, right? There's language that really kind of conflicts with the user interface, right? Like in the API, a symbol is a family type, but in Revit environment, a symbol is a 2D symbol. So there's a little bit of, they weren't really talking to each other when they developed them, but whatever. Dynamo kind of uses more of the API programming because that's what it touches, and that's exactly what this one of your fine board members was saying, that it is a reference to the API, absolutely. But anyway, you don't need to know that. Just go select geometry, click select, okay? And then they come kind of wave over here, and boom, there it is, okay? There we go, right? Now, sometimes you have to do something a little extra just because Dynamo gets a little confused. Sometimes you have to kind of extract the geometry. It's kind of like an here we're going to do a, let's see here. We're going to go to geometry. Now we're doing geometry. Okay, we're building Dynamo geometry. Geometry here, action. Oh, no. Hold on. Wait, no. That's not right. Revit, element, action, geometry. There we go. I know it took a little while. Basically, this is saying, okay, Revit, translate what that really is. What is it really? Okay, wire it up. Select edge to element geometry. This element geometry is just a basic kind of explode node, okay, without getting into it a little further. Now we're going to do something very special. We are going to run Dynamo for the first time. The reason I'm running Dynamo for the first time, and you can do that, have unconnected nodes, is you want to start to see if things are flowing right. And here's the first lesson you need to learn. We selected that edge. We hit. By the way, does anyone see any geometry inside of this canvas inside of Dynamo? No? I'm going to hit run. Better work. We'll talk about why that's yellow. Okay, look, what happened? Look here. See? Look. You see that? Now. You see that? That's at, whoops. They got to get better rotation functionality inside of Dynamo. But anyway, you see that? You see that curve? That's the same thing, except that now is not Revit geometry. What is it? What is it? What is it? Dynamo geometry. So here's your lesson for today, because this confused me so long and the developers were no help. If you see the geometry inside of Revit, it is Revit geometry. If you see the geometry inside of Dynamo, it's Dynamo geometry. It can't be simpler than that, okay? So if your curve's not there, what is that telling you? Dynamo, it's not Dynamo geometry, okay? So get it to Dynamo geometry. Now, can anyone tell me what we're going to need to do? Why is this null? I don't like that. But anyway, let's keep going. We're going to feed that into curve, okay? Let's keep going. Don't like that that's yellow. But anyway. Now, with a 3D beam, we have to actually put levels, even if it was 2D. But level doesn't really matter. But we can just lay down a level. Okay, so this is basically, so now all you're doing is just kind of going back down to select. We go to level. See here? Do you see how kind of interactive this is, right? You don't have to be typing in all this commands. I don't know. We'll set it on level 3 just for fun. Okay. Question was, good question. Are these levels automatically populated? The answer is yes. So if you had 100 levels, the names would show up on this pull-down list. So when you are getting to be Dynamo programming experts, you need to make sure you keep that model nice and clean, because as you start to pick your family types, it's really going to populate that list down. Yes, question there? What happens? Okay, another question here. Question was, what if you switch the active document? I should bring that up now. Thank you very much. Dynamo right now, as it is, I opened up this project environment and was working and doing some stuff, and then I fired up Dynamo. Did everyone see that? Right? Dynamo knew, okay, that is the active document. I'm going to latch onto that database. Okay? That's what's happening right now. And if you look closely, there's this little yellow message down at the bottom. It's not there anymore. It just says, I'm linked to this view. Okay? Now, the question was, what if you change the active view? Yes, you could open another session of Revit, okay, and make that window active. Then all this would become grayed out, and you couldn't actually run the program of Dynamo on a different session, so to speak, active document, because it's looking for this. It's not looking for that other one, okay? That's just the way it is. And really, Dynamo, if you're starting to get it now, is really just a tool for your back pocket, okay? It is a personal friend, okay? So as you start to build stuff in Revit, you're like, okay, here's my roadblock, right, which is I'm moving that wall and that beam's not moving. What do I do? Could Dynamo help me? Oh, let's try it. Open it up, lay those nodes down, see if it'll help you. Okay, that's really what it's for. If you start to try to link it to multiple objects and trying to deploy it across all your offices and trying to do that stuff, it's really designed as a personal functionality attachment, increase attachment to Revit, okay? At this point in time, that's what it is, okay? Is everyone kind of clear on that? Yeah? But if they don't have Dynamo, you could send this definition to your friend. It's a real small file. It's a DYN, and they could open up these nodes and that same file and hit run, and it would do the same thing. Okay? So it is what it is. Okay, level, this is 3. Let's do 3. Let's keep going. Up vector basically is just the Z vector. All we're going to do is lay down. We got to go to the geometry. Anytime a beam wants to see width, if it's a wide flange, you want the web to be vertical, and in that case, you'd want to have a Z pointing up. I'm not going to get into vectors. It's all in the handout. There's a whole theory on vectors. You can kind of get lost on it. But anyway, I'm just going to lay down a one that is in the Z, which just means that it's basically web is pointing up. Okay, that's usually how you'd want to be doing this, is web pointing up. Structural type basically is, I know I'm moving a little fast, but just basically I'm filling these in. Okay, that's all you need to know. You don't need to remember this. Then structural type, basically, that's a little odd, but it's basically you have to tell it whether it's a structural, whether you have to tell it whether it's a structural beam, a structural column, or a structural family. Here we are. Here it is. And that's a beam. I don't know why the developers do that, but anyway, you have to do that. And then next is the family symbol, which is the really important one, which is the structural framing type. Okay, so we go here to Revit. We're going to go to select, and we're going to select the actual family, structural framing type. Okay, and that goes back to that gentleman's question, which is this list will be populated by all the structural types that are in Dynamo. Okay, so we're going to go here. I picked that nice big beam there, and I'll feed that in. Okay, now I think we got everything kind of lined up. I don't like that. That's question was, and it's a good question, which is it bidirectional? If you load more types in, like a W24, would that automatically populate? Yes, if you hit that button run. Okay, but you could run the whole. I'll get you in a second. I got to finish my because we're. You could run this automatically, and it would do it automatically, and we'll get to that in a second. Okay, so let's try to hit run and see what happens. Did it work? Uh-oh. What did I do? Hold on a second. Uh-oh, I don't like that. What did I do? It's all my monologue. Holy smokes, let me save this. What happened? Hang on a second. Okay, let's see here. Let's try it again. Let's close it and try it again. Maybe because I was doing a lot of talking and hand waving. Well, let's just hang on a second. Let's just try it again. Okay, here it is. Ah, it didn't like it, did it? Okay, hold on. Let me close this. Close this. Let me open it again. Sometimes it could be fussy, especially if you do a lot of things to it and then you fire up Dynamo. But just I did select edge. Just hang. Let me run through it one more time, everyone. Hang on, Nat. Okay, let me do something. We'll see if it works. If not, we'll just run the other definition. Let me try it again. Okay, here we go. Here we go. There we go. Okay. So then we do this, we do that, and we join this and this. Do we join it? No. Join this and this. And we've got to switch the join. Woo! Okay. I get extra warm when these things don't work. Okay, here we go. Okay, so then we've got to switch the order. See you later. Hang on, everyone. Okay. If you have to leave, go ahead. Let's see here. Okay, there we go. Let's just try it again. Okay, here we go. Dynamo.
So with Dynamo, you still need the wall to make the edge.
At the moment, yeah. Just kind of for simplicity. The question was, did you need the wall to make the edge? Yes, you did, but you didn't have to do that. Just because we did that example, we did it that way. But let's show. There we go. Okay. Let's try it. Oh, it's not working. Okay. Let me open up the one that's pre-baked. I don't know. I won't have time to go through it. Hang on, everyone. I don't have time to go through it. Curve, beam, final. Let's see. Hold on a second. I don't know what's going on. Hang on a second. Did it go? Oh, now we're having trouble. Well, anyway. Okay. I got to move on, but it would have worked. I don't know what the problem is right now. Let's move on. I don't know what the problem is. Worked before. Let me see. I'm just going to need to move on. Let me try it one more time. Edge. Let me grab a different edge. I don't know what's going on. Did it do it? I'm having problems with this. Okay, I'm not sure what the problem is, but anyway, we'll fix it later. Okay, but that. Yeah, you would hit run and the beam would appear here, and then you'd slide the wall and then the beam would move with it. It would appear in Revit, yes. So it might be that edge is a little finicky. Let me. I'm sorry.
Yeah, that's what he's been doing.
Yeah, I'm gonna pick a different edge just for now. Let me just see if we can get a different edge. Okay. Just for something. No, it's this one. Not sure what's going on with that. Anyway, the hand was working. Okay, let's move on. But basically, that's how you'd set it down. This extracts the edge geometry, and then this should actually be reading curve. Yeah, you would. And you would. In fact, in the handout, I have something called the multiple, which is this one. which is basically, which is this one, which basically what you do is instead of actually, see how we're laying beams down here in each one of these? Instead of just laying it in one, Dynamo actually works in lists. And so what you would do is you would actually select, each one of these grids, and then you would extrude them up in the Z direction, and then you would do a curve intersection. And then with that curve intersection of the surface, then you could actually create them. But right. In fact, that's right. I have an easier one. Let me just see if it works. Hang on a second. These edges work. Open. Hang on now. All right, let me pick a different edge, like this edge. Is that what it was? I didn't need that. Come on, pop up. Oh, I'm having trouble here. Oh, no. I'm sorry? Often. Let's see. Yeah, I'm having trouble with this thing. Oh, I didn't need the I didn't need the geometry. Did someone say that to me? Who said that? Yeah, I didn't need the extra geometry node, huh? Okay, anyway. All right, anyway, let's move on. Ugh, okay, I don't want to spend any more time on it. But basically, you would do that, and you would not need that other node. I guess that's what you're saying, right? Okay, let's open it again. So basically, open. Let's try it again. Let me just show you, or explain it to you. Open, edge. Here, topo. Home. Here we go. So I wouldn't need to extract it. Is that what you're saying? This one. Hang on. There we go. Okay, so I put in an extra one. All right. Anyway, you get the idea. Thank you. Okay. Yeah, so you don't need that extra node in there. Sometimes you do, though. Okay. Cool. Let's talk about topo. All right. Everyone clear on that? Select edge. All right. There it is. Anyway, I put it up, but it's supposed to be down. Okay, so let's talk about topo. Let's talk about topo. So how many people have used yeah, but I don't want that one. All right, let's see. All right, let's talk about topo. Now, let's see. How many people have actually used topography inside of Revit? Okay, how many people actually love the topo tools inside of Revit? How many people love them? Yeah, how many people hate them? How many people think the tools are kind of clunky? Yeah, okay, cool. I'm glad you think that, because you're the right crowd to talk to. Okay, we got 10 minutes. Let me show you this real quick. Hope it works. The problem with topography is that you basically only have a few tools to model in, right? You've got your placement point, and that's about it, right? You don't get the gamut of all the other tools. You don't get the spline, and you don't get all that, right? Okay, so what has troubled me in the past was if I had a retaining wall that was shaped like this, okay? You see this? If I had a retaining wall that was shaped like this, and I wanted to actually tuck the soil right up against it on one side and then lower on the other, it would be a bear to do it, right? The handout shows you actually how to place nodes and then like slide the topo nodes into place, okay? But you don't need to do that if you have Dynamo, right? You can actually use that same concept. And I think I'm going to kind of jump to the end. But if I open up, if I open up this, you have to leave. Go ahead. Let's see here. Okay, let's start from here. It's basically the same concept. Okay, so if you wanted to do that, do you see what I've actually created? Do you see how I created this topography where you actually have the topography follow the exact shape of that? Do you see that? Now, if you were going to do this with the graphical interface, it would take you forever, wouldn't it? So if you had topography and you needed to shape it to something that was actually down a few feet from that wall but follow that shape, on the other side it's actually down a few feet lower. In order to have to manipulate every one of those nodes, it would take you forever. Okay? What's really good about Dynamo is that you have actually the ability, let's delete this. You actually have the ability, hey, where's my, must not have masses turned on. You have the ability to actually pick elements inside of Dynamo and then shape topo accordingly. So do you see these two lines? I actually pre-baked these. Do you see these two lines? These lines are basically mass lines, in-place mass lines that would represent where you'd want the soil up on the wall on one side and then up on the wall on the other. Okay? So all you need to do in Dynamo is pick those two lines, and then Dynamo will actually create the topography to actually match those points. And so what you do, I'm going to open up a finished one here. Let's see here. Okay, so if you go to Dynamo, this definition is available to you. I go to topo, let's see. Let's see here. Okay, this is working before. Here we go. I actually had this problem in my office. And so I was actually modeling all those nodes. Oh, it was taking forever. It was really a mess, okay? So all you do is you place down your select model element, and that's going to be your topography, okay? And then what you do is you extract topography points, okay? So what we want to do is anytime you want to make new points inside of any new points in topography, you have to actually extract them first. And so this topography is just 4 points, one on each corner, right? You want to add intermediate points in between, which would be points along that curve and points along the other curve, okay? So the first thing in Dynamo you do is you select that surface, okay, and that's what this is, right here. Okay, you select the element. And the next thing you do is you extract those topo points. Okay, you see that? So this extracts the topo points, and it puts them into a list. It's okay, put those 4 points in a list. Next, select that curve, the low curve, okay? And then there's the element geometry. And then put it in a list. And then this curve point parameter, what that does is it actually, inside of Dynamo, you're actually able to just, oh, really? Oh my goodness, come on. Let's try this. Inside of, man, I'm having trouble. There we go, that should be that one. Okay, and then this one should be this one here. Okay, hopefully this runs. Then we're going to run it. There we go, okay. All right, so you see these points, what it's doing is you're saying, okay, now all you do is find the curve that I selected and divide it by an equal number of spaces, and that one you can actually do any way you want. And in this case, I actually set it up on a slider. Do you see here? So if I run automatically and you want more points along that curve, all you can do is just set it up on a slider. So you can slide this along and it'll change the amount of points on there. You see that? Should be changing. Should be. Yeah, you see that? How it's changing the number of points, the discretion on there? Okay. So then you do that with each curve, and then you feed that into another list, add all the points together, and then shove it out to topography by points. And then that will build a new topography that then has this surface on it. You see that? You see that? So that's actually how to make a retaining wall. And then if you actually look at that in elevation, you have something beautiful. Watch this. I'm sorry, if you look at it in section, you have something awesome. You see this? Let's see. Hide. Look at that. You see how pretty that is? That actually makes that as a nice retaining wall. Okay? So if you need to create a retaining wall inside of Revit, just draw a line on one surface, draw a line on the other, lay down your dynamo nodes, pick that topo, pick the line on this side, pick the line on that side, put all the nodes together and run the topo by points, and it'll automatically generate a section. I mean, it'll generate a topo surface like that. That's basically a retaining wall. Okay? And so what you can do is you can play with it. Watch this. So in my office, the problem we were having was that the height of this upper one was constantly flopped around, and the landscape architect kept telling us, the structural engineer, no, it needs to be 6 feet from the top, no 7, no 8. They kept putting plants and they were sticking over, and the neighbor next door was complaining about the way it would look. We see all the plants. Okay, it needs to be 5 feet. No, it needs to be 6 feet. No, it needs to be 8 feet. No, it needs to be 10 feet. You're like, just make up your mind. This was when I had to do it on brute force method. But if you have Dynamo, all you need to do is actually just set another equation in there. And this is what I did. Do you see this Z value? Okay. All I did, and this is Dynamo, this is design scripting, which is really simple. I just said, okay, this is my Z point, which is the row of points on that back face, right? Instead of making it equal to whatever it is, subtract that amount and put it in an equation. You see this? See, it says Z minus input. So you feed in your Z. So all you do is you type in Z minus input. That's all you do. Okay? And if you did this in your office, you're automatically design scripters. That's how simple it is. Okay? And it sees these two variables and says, okay, feed in Z, feed in input. That's it. And it doesn't have to be input, it can be anything you want. So this Z value we fed in there. Okay? And this is the actual offset that we started with, and we feed that in there. Okay? So now, if they keep going around and around on it, then you could just change this number. Hopefully this works. This is in feet. Hopefully this works. Come on, come on. There you go. You see that? You see how I moved? Okay, but no, we're not done. We're not done. They're like, no, I want it to be half a foot. No, 6 inches. No, and you're like, all right, I got you, man. So you say, hold on a sec. You say, when you make up your mind, put the offset value in here. Landscape architect. Send them that file, send them that Dynamo definition, and wash your hands of it, okay? There you go, right? So then they open it up, they go, oh, now I can play with this. And that's the whole point, right? Dynamo now has that gentleman, you're still there, still has that component in it, which is that design computation, which is I don't want it at 1 foot down from actually up there. I want it a little less. No, I want a little more. No, no, no. You can do those iterations. You can actually host plants on there and watch them flop up and down. You can do that because now you have the computation at your fingertips. You have those Z values of those points, which are on that curve, which is hosted on that wall, which is building that topo. You see how that works? So this is all integrated together. And then you do the computation in Dynamo. Then you send those Z values to the topo node, and the topo says, okay, I'm going to rebuild you in Dynamo. Do you see how that works? So you can kind of have this back and forth thing, and it really is a beautiful thing once you get it going. So do you have a question? Question was, have I seen this? You mean this in practice? Absolutely. Have I seen Dynamo in practice? Absolutely. I use it every day in practice. I do have a day job, right? I use this all the time. We actually built inside of Revit. The one I'm working on right now is inside of Revit. We have graphical column schedules that are concrete, and we have to show the rebar in them, but it doesn't show rebar. But you can build rebar. So Dynamo extracts the rebar and then builds it in the family, so you can see it in the column schedules. So it's just endless. The possibilities of this are just endless. Have I seen this in practice? Yeah. Do I use this in practice? All the time. The question was, does this enable structural analysis? Dynamo directly? No. But you have the geometry to extract. You have the geometry to actually place it into structural analysis software. Yes?
You can also extract CSV files from the data, right?
Question was, you can extract point files of all the data. Absolutely. You can bring in point data. You can send out point data. What we didn't have time for is actually you can write this stuff back to Excel and bring it into Excel. So there's all those opportunities. It's all in the handout. Okay. So I'm gonna stick around for a little while, maybe another half hour, if anyone has any questions. But we'll kind of end it there. But I think you kind of realize that Dynamo really has a lot of applications. Just remember, it can read anything and write anything to Revit. And just get that straight. Dynamo geometry, Revit geometry. Get the two environments straight and how you actually lay down those nodes. And okay, well then go out and do great things. Okay, thanks. Thanks.
What was your process for learning all these commands and nodes and just trial and error?
Yeah, just getting familiar where it's at. Yeah. Yeah, the Eastings and Northings, yeah. Yeah. Yeah, you could. Yeah. Hey. Hey.
I have a question. So, hard time applying this to my workflow right now. Like, when you decide to use Dynamo, or only for like complex shapes, or
Whenever you can't do it in Revit.
so it's not goal, or
It doesn't have a goal. It just